Hello everyone, I am Bradley Sward and this is my Day 21 Part 1 solution to Advent of Code 2024. The problem is called Keypad Conundrum and I'm solving it again, almost as always, in Python. So the problem is pretty complicated, I guess. You are a person and you need to control a robot who needs to control another robot who needs to touch some buttons to open up the ship so some guy can get out, some elf can get out. So basically, you are controlling a robot who touches this to program a second robot who touches this to program whatever the code is. Or is there a third robot? I think there's a third robot. There's three total robots in play here. You need to do this code for robot one, but you need this to tell them to do what to do, and then you need this to tell them what to do, and then you need this to tell them what to do. And so that's the fun part of all this, is trying to figure it all out. And again, part two is making, doing this in an efficient manner because we have limited time, because this person is probably dying of radiation in there. And oh boy, right? Like, well, what do you think the poor elf is doing if we can't go in there due to the radiation? But whatever, oh man, let's get this done quickly, right? So solving all of this, I'm supposed to get an answer of 163,920 when you multiply the shortest length of what you need to tell the robots to do, the first robot to do the second robot to do the whatever, and then after that, then multiplied by the number, the complexity of the code minus the a, so 29 and 980 and so forth. So my code is not pretty. My code gets the job done. Let me run it. It takes a minute or two here. Again, it's the end of the year here. I don't have time to do all of these as I would like to. I don't have time to put into thought, and their problems are getting harder. So anyway, so here is our numeric keypad. I'm keeping track of it as XY values. Same for the directional keypad. And then I'm maintaining this so I can this power set so that I can get all the combinations of A, B, C, so that I can try all the different permutations of that. I'm setting up a map, so if I'm trying to go from 7 to 0, well, all this code will get me basically all the movements that I can do from 7 to 0. Let me at least, let me start over, since let me just show you, and then we can go in here. So just to say, and again, part of the problem here was that because of the way the layout is in these layouts, they say that if the robot goes over this square or this square, they go crazy. And it really does matter, because it really does affect the end result. So you have to take into account that you can't go over this spot, which kind of made everything more complex in the end here. But anyway, just to say here, where's my breakpoint? So I go through a ton of code just to try to make sure, but like for this, the numeric keypad, you can see that if I'm trying to go from 7 to 7, there's nothing to do. If I'm trying to go from 7 to 8, I have to go right. But like in this case, if I'm trying to go from 7 to 0, it's missing the one that says try to go down, 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 and right, because I can't do that. So this is this is the list of all the moves that you could possibly make from any position on the numeric keypad to any other position on the numeric keypad. So I have a map of those structures, and the same would then go for the directional keypad. I have a map. I'm trying to go from here to there. This is all the possible ways I can get there. And since this one's much easier and smaller, you can't do more than 2 ways to go about it. So anyway, so all that code does that, and then down here, now we can actually program the robots. So the first robot uses that, and basically, the first robot is the robot that needs the numeric keypad. So we go off of that, and we say, okay, starting from starting from A, that's where the finger points. Basically, let's go through and try all the different combinations, and basically, I wish, and again, I should have showed you, but it'll show you that, like just like in the data, it'll give you all the different paths to get, not just the best one. I'm not sure right now if I need to do that, because it doesn't look like I do. But there's my solution. Here's my 163,920. So there's an answer, and again, it computes it in a reasonable amount of time. But you can see here. Let me run this again. This is probably, did I get rid of that other breakpoint? Nope, not yet. And so here, basically, for the first one, whatever the input here. Whoops, come on, mouse. For 671A. Basically, to get the first robot, to get the one that's touching the numeric pad, I need to tell him to do any one of these 6. Is it 6? Any one of these 6 will do. But then at the end of the day, my thought is, well, does which one I pick matter? That's what I'm not sure yet, and I have to run for part two. And if it doesn't matter, well, this will be much simpler because I just have to turn this into a loop and I'm done. But for the second robot, it's the same idea. It's just a matter of right now I'm computing all the possible paths that get me there of the minimal length. And there's 48 for this one, and then good luck for part three, right? So this is where it takes forever. But anyway, so then, so because it's doing 40 or however many different, I already forgot the number. So anyway, that's part one. And then when you're done with everything else, it prints out everything and whatever this, and then I sort everything from low to high by length. And basically then for each one of these, once I get the length of whatever all the possible things of the robot could do, what is the smallest one, and I multiply that by the number, and I keep going and going, and again you see the answer comes up as 163,920. So I'm looking to part two. It's either going to be really easy or really hard based on what I've already written. I'm hoping for easy because then I have to loop this and just modify this slightly. But if not, I am in for a trek, and I'll see you guys in a few days. So have a good one, everybody. Take it easy. See you next time.